Namaste students, welcome back to Rama Teaches You. Today we are going to do class 11th physics chapter number 4, motion, laws of motion. Okay, so we have already completed the first three, and in the third chapter we finally understood how to describe a vector in two different quantities, in two different sections. We call it resolving a vector, right? We can resolve a vector in the x direction as well as in the y direction. Now, we are going to use that knowledge and apply this in this chapter. Okay, from here onwards, every single physics chapter will require us the knowledge of vectors. Okay, so forces and laws of motion. This is a continuation of the ninth class chapter of force and laws of motion. Okay, the same chapter is going to get continued in 11th class. So the first few sections, the first few pages of this chapter will give us a brief introduction of all the things that are required, that we have already learned. It's just a brush up. It's just going to be a brush up of everything that we have learned in ninth class, and then we'll slowly advance towards complex systems. Okay, in the ninth class chapter, the last topic that we did was what? A system of particles. A system. How do you resolve all the forces that is acting on a system? Okay, so here we are gonna extend our knowledge. We are gonna extend our knowledge base to the next section. Okay, so we start with Newton's laws of motion. Motion is an integral part of most of the natural phenomenon. Galaxies, stars, planets, satellites, all are in continuous motion. Motion of these bodies is governed by and regulated by certain laws. Okay, so everything that moves is governed by certain set of laws. Laws hidden behind these motions in nature were discovered first by Isaac Newton. Therefore, these laws are also known as Newton's laws of motion. The cause of motion is described by an additional concept, acceleration, which is produced by making an effort on a body in the form of a push or a pull. We know that if you apply a force on a body, if an external force is getting applied on a body, the body experiences a force, right? The body could be at rest, the body could be in constant velocity, but as soon as we apply a force on the body, what ends up happening? It experiences a force. It experiences a force and then it accelerates. Force and acceleration go hand in hand. If you want to have force, you have to accelerate. Okay, now the cause of motion is described by an additional concept, acceleration, which is produced by taking an effort in the body in the form of a push or a pull. The name of this push or pull is known as force, without which there is no motion. Without force there is no motion. Understood? Everything would be at rest. Force. Force may be defined as the external agency, a push or a pull, which changes or tends to change the state of rest or of uniform motion or the direction of motion of an object. The dimensions of force are mlt minus 2. And the SI unit of force is what? The SI unit of force is newtons. A force applied on an object can have the following effects. We know all the five, right? It can change, it can move an object from rest, it can bring an object in motion to rest, it can change the velocity of an object, it can change the direction of an object, and it can change the shape of an object. All these five and many more, many more. These were the five that we learned in ninth class. Okay, the characteristics of force, how force acts on a body, and what are the various changes the body experiences when a force is applied. Okay, did you understand this? Okay, next. Okay, so some important points about force. A bar magnet can attract an iron nail from a distance. This force shows that external agencies of force, electric and magnetic, can exert a force from a distance. Okay, so how did we understand this in the beginning? In ninth class, we had something known as contact forces and non contact forces. It was an introduction. We knew that there were some forces which can only occur if there is a contact between them. For example, the muscular force and the frictional force. These two forces can only affect a body if there is a direct contact between them. I can only pick up a mug if I'm physically holding, physically in touch or contact with the mug. I cannot simply think and make the cup float in front of me. Right. So a non-contact force is what? A non-contact force is a force where you can apply a force on an object without actually coming in contact with the object. Okay, so bar magnet has a magnetic force. A charged particle has an electric force. Earth has gravitational force. That is the reason why if we drop something, it falls straight towards the ground because the gravity, which is a non-contact force, is getting applied. Gravity, which is a non-contact force, is getting applied on the body, and this causes the object to move. Okay, so force is a polar vector as it has a point of application. Force is a vector quantity. Okay, it has both magnitude as well as direction. Okay, so if you are applying multiple forces on a body, the resultant force will allow the object to move in the direction in which all the resultant forces are getting added to. Okay, that is known as what? A vector. That is why forces are called vector quantities. Okay, for the vector sum of all the forces acting on a body is called the net force or the resultant force. In ninth class, that was a topic. That was the term we used, the resultant force. Okay, so Drupad, what is the resultant force acting on a body at rest? What is the result? Zero, right? If a body is at rest, then all the forces that are acting on the body are not able to make the body move, right? So there is no acceleration taking place. So if all the forces acting on a body make the body stationary, then we can say that the sum of all these forces will end up being zero. The same case is for if an object is traveling in uniform velocity. In this case also, what is happening? Some of all the forces acting on the body are unable to change the velocity of the body, right? They are unable to change the velocity, therefore the acceleration becomes zero. Therefore what happens? The net force applied on the body automatically becomes zero. Clear? Now we have to learn something called inertia, the inherent property of a material body by virtue of which it remains in its state of rest or of uniform motion in a straight line is called inertia. Okay, so inertia is a property of any material. Any material that has mass has inertia. So mass is directly proportional to inertia. Okay, the more mass you have, the more inertia you have. The various types of inertia are what? Again, this is a ninth class topic. There are three types of inertia. There is inertia of rest, there is inertia of motion, and there is inertia of direction. Now, what is inertia of rest? Now, Bripat, imagine you are sitting in a stationary bus. You're sitting in a stationary bus and the bus suddenly starts to move. Where do you think you will move? Will you move towards the back or will you move towards the front? Imagine that the bus is moving in the forward direction and you are facing the forward direction. Where do you think you will align yourself? Will you go front or will you go back? We will go back because the inertia of our body was stationary with the bus. When the bus moved, our body did not know that the bus was moving, so it tried to oppose the change, and to oppose the change, what happened? We moved towards the back. That is one of the major reasons why we have the back, what do you say, back, that slide, the stand that we have, okay, to allow us to not fall or trip over. Okay, this is known as inertia of rest. Initially, the body is at zero velocity. So, if you somehow increase the velocity of a body, the inertia will try to oppose it. The inertia will try to oppose it. And this will allow the body to react in such a way as to oppose the force, or the oppose the direction of force. Clear? Now, this is known as inertia of rest. What is inertia of motion? Okay, in inertia of motion, the body is already having an initial velocity. Suppose you are traveling in a bus which is going at, like, let's say 50 kilometers per hour. Okay, it is going at a speed of 50 kilometers per hour. So what do? You are standing in the bus. Okay, now imagine there is a dog that is suddenly if a dog suddenly appears in front of the bus, what happens? The driver applies brakes, right? The driver applies brakes. Now suddenly what happens? The bus stopped, right? The bus stopped, due to which what happened? Because the bus stopped, our body, which was having the same velocity as that of the bus, okay, inside the bus, Drupad, we are not having zero velocity. We are sharing the velocity of that of the bus. Okay, so if the bus is traveling at 50 kilometers per hour, we are also traveling at 50 kilometers per hour. Okay, so when the bus stops, what happens? Our body, which was moving forward, now suddenly is experiencing a loss of motion. Okay, therefore what happens? Our body wants to move forward. Our body wants to move forward because our inertia was initially in the forward direction. It was moving in the forward direction with a constant velocity. Therefore, what happened? As soon as the brakes happened, as soon as the bus stopped, our body leaned forward or backward. Our body leaned forward because that's what the inertia was directing our body. That's where the inertia was directing our body. So initially we will trip ourselves, we'll hit ourselves. Okay, if the bus is traveling really fast and it comes to a stop, we may even damage our head by falling face forward. Okay, understood? So this is known as inertia of motion. Now, in inertia of direction, what happens? Again, imagine you are in a bus. You are sitting in a bus and the bus is moving straight. It is moving straight with a constant velocity. Now, it is not changing its velocity. Okay, it is not changing its velocity, but it is changing one thing. It is changing its direction. Suppose it is moving forward. It is moving forward with a uniform velocity of 50 kilometers per hour, and it moves towards the bus driver decides to take a right. The bus driver decides to take a right. Where will our body lean? Will our body lean with the right side, or will our body go to the left side? Why will it go to the left? Again, what is happening? Our body had an initial velocity, our body had an initial inertia, and the inertia was moving in a straight line. So even if the bus turns, our body tries to lean towards the left, so as to keep in the same path as the forward direction. Okay, so basically, if the bus is moving towards the right, our body will slowly lean towards the left because that's where our body was initially going. So, to compensate for the right direction, our body will lean towards the left direction. This is known as inertia of direction. And did you understand the three inertias, right? Okay, next. Isaac Newton's law of motion. Sir Isaac Newton made a systematic study of motion of bodies. He arrived at three laws of motion, which are called Newton's laws of motion. So, what is Newton's laws of motion? The first law of motion, these are laws that will never change. Even if you are studying this in an advanced class, the laws are like that. Laws that do not change with grade, with basically age. Okay, so the first law of motion states that an object at rest stays at rest. An object in motion or in uniform velocity, in uniform motion, stays in uniform motion until and unless an external force is applied on it. Okay, so it will only accelerate. An object at rest will only move if you apply force. An object in motion will only accelerate if you apply force. Understood? That is known as the first law of motion. The first law of motion by Isaac Newton is also known as the law of inertia. It is known as the law of inertia. Okay, this law states that every body continues in its state of rest or of uniform motion in a straight line unless it is compelled by some external force to change that state. The state of rest or uniform motion both implies zero acceleration. The first law of motion can therefore be simplified as follows. If the net external force on a body is zero, the acceleration is zero. As simple as that. Okay, if the net force is zero, the acceleration is zero. Acceleration can only be non-zero if a net external force is acting on it. Okay, so Newton's first law defines force qualitatively. Okay, it defines the force qualitatively. The Newton's first law is categorized in three parts. A body at rest continues in the state of rest. An external force has to be applied on it to make it move. For example, if a book is on the table, the book is on the table, it will be on that table at that position till the end of time, until and unless an external force acts on it. Okay, until and unless an external force acts on it. Clear? Crystal? Okay, next. There is another important thing that I could tell you. Have you seen those magicians and those trick artists? What do? There is a tablecloth on top, and then if you basically pull the tablecloth in a certain motion, you can basically remove the cloth without moving even a single object on the table. And you know why that is possible? It is only possible, of course, skill is involved, but Newton's first law, that is, an object stays at rest until and unless an external force acts on it. He is applying a force on the tablecloth in such a direction that the net force on the object above the cloth does not change. The net force acting on the object does not change. So when he pulls the cloth, okay, from underneath the table, from underneath the object stays at that position. It does not move at all. Clear? Is there any doubt here? Okay. So since the book is observed to be at rest, the net external force on it must be zero. According to the first law, then the weight is always equal to the normal force. What is the normal force, Drupad? What the force perpendicular to the what? The force perpendicular to the surface on which the object is placed. Okay, it's not perpendicular to the object. It is perpendicular to the surface onto which the object is placed. The normal force can have different values depending on where the object and how the object is aligned to the surface. Okay, so the surface is a very important thing. Normal to the surface of the object is where the normal force lies. Clear? Normal to the surface. That is the actual meaning of that term. Normal to the surface. Clear? Normal to the surface. Understood? Next. Okay. The second part. If a body is in motion, it continues its motion in a straight line with a uniform speed unless a net external force is applied. Until and unless you apply a net external force, the body will continue. The body will continue to move with a uniform velocity. Understood? Okay. Now, next, this ball, for example, a ball rolling on a frictionless surface. A ball rolling on a frictionless surface will move till eternity. Okay, because it won't be slowed down. Usually, when we roll something on the ground, why does the ball stop? The ball stops because of friction, right? The ball stops. Eventually, the ball stops because of friction. Even in the smoother surface like ice, the ball will eventually stop. It will eventually stop because even in the smoothest surface there is some amount of friction involved which causes the ball to stop. Clear? So if there is zero friction, the ball will just keep on moving and moving and moving until and unless the time ends. Now, the third part says that the body moves with a uniform speed in a straight line, cannot change its direction of motion. So a force is required to change the direction. Understood? A force is required to change the direction, because changing direction involves changing the direction of velocity. And what we know, that we really know that the if we want to accelerate an object, we either change the magnitude of velocity or we change the direction of velocity. One of these two has to be done. Then and only then what will happen? The object will try to accelerate. Clear? Okay, next. The third part says that, okay, this is done. Now, a ball thrown downwards changes its direction towards the ground due to the force of gravity normal to the direction of the motion of the ball. Okay, because I am trying, if I drop a pen like this, the pen will always go down. If I drop a pen like this, again the pen will go straight down. The pen will not, just because I drop like this, the pen will not go like this. Okay, that is because there is a direction onto which the gravity is falling. Okay, so basically if an object is falling, it will take the path onto which the force of gravity is taking place. Okay. Okay, next. Newton's first law defines the inertia. According to Newton's first law, an object continues in its state of rest or uniform motion until and unless an external force acts upon it. This depicts that objects by itself cannot change its state of rest or of uniform motion along a straight line. Thus, first law defines inertia, and so it is rightly inspired by the law of inertia. So first law is also famously known as the law of inertia. So any doubts here? Like, do you want to ask any questions that is bugging you or something like that? No, right? Okay, let's go. Momentum. Now, if a body is moving, then it has momentum. Okay, why did I say a body? A body means anything that has mass. If something has having mass is moving with some velocity or the other, then it has accompanied itself with momentum. Okay, so momentum will take place if a body is in motion. Understood? So momentum of a body is defined as the mass in motion along a straight path. The amount of momentum depends on the mass and the velocity of the body. So numerically, it is a product of its mass and velocity, and it is denoted by small p. Okay, momentum is denoted by small p. Now, momentum is equal to mass times velocity. Now, the SI unit of momentum is what? Kilogram meter per second. Because we are multiplying mass and velocity, so obviously what will happen? The SI unit will become kilogram meter per second. The CGS units becomes what? Gram centimeter per second. Okay, okay, gram centimeters per second. So dimensionally, what is the dimensional unit quantity of momentum? M L T minus 1. M L T minus 1 becomes the dimensional quantity of momentum. What is the other quantity that we have learned in ninth class that shares the same SI unit as momentum? There is another quantity that shares the same SI unit as that of momentum. Just like energy and work done have the same SI units, similarly, momentum shares its SI unit with some other quantity. Could you please tell me what that is? Through impulse, exactly, yeah. Impulse is what? Change in momentum. Change in momentum is called impulse, exactly. Be confident with your answers. Now, variation of momentum. Let two objects, each of mass m, moving with different velocities v1 and v2, with v1 greater than v2. Then p1 becomes what? mv1. P2 becomes what? mv2. So we can say that the momentum is directly proportional to the speed with which an object is traveling. If an object is traveling with a very high velocity, then it has a very high momentum, right? The faster you are, the more momentum you have. That is the reason why people say speed kills. Why does speed kill? Because the more faster you travel, what happens? Your momentum is increasing. Since your momentum is increasing, it also increases the risk of death, accidents, and injuries. So that is the reason why the statement comes: speed kills. So because you are traveling at a faster speed, what happens? You end up having a larger momentum. Understood? So we can say that P1, the momentum is directly proportional to velocity. So if we try to graph this value, what will we get? We will get that momentum is directly proportional to velocity. So it will be a straight line. Understood? Okay, next. As V1 is greater than V2, so P1 is greater than P2. It is a graphical representation in the above figure. Thus, the momentum of bodies having equal masses are proportional to their velocities. So, momentum becomes proportional to velocity, or in other words, P1 upon P2 becomes equal to V1 upon V2 if the masses are the same. Clear? Similarly, now, if your mass is increasing, then what happens? Let an object of mass m1 and a lighter object of mass m2. Suppose both the objects are moving with the same velocity. Now what happens? Now the momentum is now totally dictated by the mass, right? So in other words, we can say that momentum is directly proportional to the mass of an object. So the more the mass you have, the more the mass you have, the more the momentum you will have. Clear? There's a huge difference between a toy car traveling at, like, let's say 50 meters per second. A toy car traveling at 50 meters per second towards you, and a truck traveling at 50 meters per second towards you, right? So who will cause more damage? The toy car might just hit you and then flip around, but when the truck hits you, you will be like you will be thrown so far away. Why? Both of them were traveling at the same velocity, right? Both of them were traveling at the same velocity of 50 meters per second. Both of them, the same velocity, 180 kilometers per hour. Okay, both of them were traveling at this high velocity. But in the case of the truck, there is no chance of survival. But in the case of a toy car, you may get injured, your bones may get fractured, but that is the worst that can happen. You will not die. And what is so different about these two cases? In both the cases, the mass was dictating the momentum, right? The mass was dictating the momentum. Clear? So, as a summary, we can say that more momentum is directly proportional to both mass and velocity. The more mass and more velocity you have, what will happen? The more momentum you will have. Okay. Now, case three. What happens when both objects have the same momentum? Now, this is interesting. Okay, so if both the objects have the same momentum, then what happens? The heavier object must have a smaller velocity, and the lighter object must gain a larger velocity, right? So so a heavier object needs to move slower, and a lighter object needs to move faster so that they could have the same velocities. Okay, understood? This portion you understood? Okay, for example, Drupal, when we fire a bullet, we know that every time every time the momentum has to remain conserved, right? Whenever a system comes into play, whenever systems actions come into play, the momentum of a system of particles always remains conserved. So if I am firing a bullet from a gun, what happens? The gun recoils. Yeah, and the bullet moves forward. So why does the bullet move with such a the recoil of a gun is not that crazy, right? But the velocity of the bullet is very, very large. Why is it so? Because the mass of the bullet is very small, and the mass of the gun is very large. Okay, so to conserve momentum, the velocity of the bullet has to be very large and the velocity of the gun has to be very small. Okay, that's why we only feel a small recoil. We feel a small recoil when we shoot a gun. Okay, and we can see that in various games also, right? Every time you basically use a machine gun, what happens? The whole screen starts to shake up. Why? Because they are trying to give you the experience of a recoil of a gun, and that is because of the concept called momentum. Understood? So momentum, if the momentum becomes the same in both the cases, then depending on the velocity, what will happen? Velocity will become inversely proportional to mass. Understood? Velocity will become inversely proportional to mass if the momentum becomes the same. So more mass, lesser velocity, more velocity, lesser mass. Understood? Okay, let's move on. So the effect of force, the effect of force on the motion of a body is described by momentum, right? So there is another definition of force. If a force acts on a body, the net force acting on a body is directly proportional to the rate of change of momentum. Have you ever heard this definition? This is verbatim from the NCRT class 9 textbook. The rate of change of momentum is directly proportional to the net force acting on the body. You have heard it, right? Yeah, that's Newton's second law. That is, see, why do we learn momentum before Newton's second law? Because Newton's second law is change rate of change of momentum, right? We are going to learn Newton's second law next, but without understanding what momentum actually is, it is physically impossible to learn and understand the second law of motion. Okay, so the effect of force on the motion of a body is described by momentum. This can be understood by the following examples. We require a greater force to push the truck than the car to bring at the same speed in the same time. Also, a greater opposing force is required to stop the truck than the car at the same time if they are moving with the same speed. Thus, mass of a body is an important parameter to determine the effect of force on its speed of motion. Mass is another important parameter to consider. As speed is another important parameter to consider, a bullet fired by a gun can easily pierce human tissues before it stops, resulting in casualty. The same bullet fired with a moderate speed will not cause such damage. Thus, for a given mass, the greater the speed, the greater is the opposing force needed to stop the body in a certain time. Thus, to describe the effect of force on the motion of a body, the mass and velocity, that is, momentum, is an important quantity. So, we have to know how the momentum is changing as a force is getting applied onto the body. Okay? We have to understand how the force is affecting the rate of change of velocity, and we come to the next law, which is the Newton's law, second law of motion. This law states that the rate of change of momentum of a body is directly proportional to the external force applied on the body and the change that takes place in the direction of the applied force. Okay, so in simple terms, the force acting on a body is directly proportional to its rate of change of momentum. Next, so let F be an external force applied on the body in the direction of motion of the body for time interval delta t. Then the velocity of the body of mass m changes from v to delta v plus delta v. That is, change in momentum delta p is equal to m delta v. So according to Newton's second law, the force is directly proportional to the rate of change of momentum. That is, the change in momentum upon delta t, or force is equal to k delta p over delta t. For us, the value of k is coming out to be 1. Okay, if we change the value of delta t to 0, then the term delta p upon delta t becomes dp upon dt. Okay, so delta P upon delta T becomes an instantaneous change in momentum as soon as the value of delta T becomes zero. It's not becoming zero, it is very close to zero. Okay, if delta T, the denominator becomes very close to zero, instead of getting an average rate of change of momentum, you get what? You get an instantaneous rate of change of momentum. So force is equal to k dp by dt, or force is equal to J dmv upon dt. Okay, now here comes an interesting part. Okay, so d by dt of a b is equal to what? D a d dA by dt plus a dB by dt. Okay, so this is how the product rule in differentiation actually works. You will learn more about this in the limits and derivatives chapter. Okay, so this is how the actual differentiation takes place. Now look at this, Tripat. We have force is equal to k d mv upon dt, right? So this becomes equal to what? K d uh, k v dm upon dt plus k dm, sorry, km dv upon dt. Did you understand what I did? Based on the product rule, what did I do? I basically differentiated each and every single term with a plus sign in between. Now here comes the crazy part. The mass of the object actually does not change, right? The mass of the object is not changing. So what happens, since there is no change in the mass, dm upon dt, the dm value, there is no change in the mass of the object, so this whole thing becomes equal to 0. Okay, so what do we get? F is equal to km dv by dt, so it becomes kma. And lucky for us, what do we see? We see that the value of k is 1. The value of k is 1. The proportionality constant is 1. So force becomes equal to ma. Understood? Now, why did I do this? Why did I teach you how to differentiate a product rule? Okay, if two or three values are getting multiplied, we have to use the product rule. Now think about this, Rupert. Where do you think it is going to get applied? Think about a rocket. Okay, it is moving forward and it is accelerating, right? The rocket, till it reaches space, it is accelerating. Am I right? So its velocity is changing. We can observe, we can see the velocity changing slowly and slowly and slowly, right? Okay, now what else is changing in the rocket? As the rocket moves upward, its fuel is slowly decreasing. Am I right? It is burning, it is constantly burning fuel. So when it is constantly burning fuel, then the mass is not constant anymore. Am I right? Mass is not constant. So that is where when we have to solve questions like that, we have to use this phenomenon. Okay, we'll have to use this. Did you understand the logic what I did here? All you need to remember is the logic. Understood? Any doubts in any of the lines? Okay, fine. So therefore, 1 unit force is what? 1 unit mass multiplied by 1 unit acceleration, that gives us 1 Newton. So a unit force may be defined as a force which can produce a unit acceleration in a body of unit mass. So if a body is getting accelerated, if a 1 kilo body is getting accelerated to a value of 1 meters per second square, then what happens? We can say that the force acting on the body is how much? 1 Newton. Clear? The force acting on the body becomes equal to 1 Newton. Next. So, Units of force. The force is a vector quantity and it is set, and its SI unit is newtons. 1 newton is defined as the force which produces an acceleration of 1 meters per second square in a body of mass 1 kg. So what is the definition of 1 newton? If a force can accelerate a 1 kg body with an acceleration of 1 meters per second square, sorry, 1 meters per second square, then the overall acceleration, the overall force that is getting acted on the body becomes equal to 1 newton. Okay, now the CGS system in centimeters, grams, and second system, the absolute unit of force is dynes. One dyne is a force which produces an acceleration of 1 centimeters per second square in a body of mass 1 gram. So, Drupad, can you tell me the comparison between a dyne and 1 Newton? What is the comparison? 10 raised to the power 5 dynes. Okay, 1 newtons becomes equal to 10 to the power 5 dynes, because 1 gram is how much? 1 upon 1000, right? So we convert 1 gram and 1 centimeter into kilograms and meters, you will get the values. Now the SI unit, kilogram unit of force, is kilogram weight. It is defined as the force which produces an acceleration of 9.8 meters per second square in a body of mass 1 kg. Where do we use kilogram weight, Drupad? Where do we use kilogram weight? We use kilogram weight for every single object on earth. Okay, because every single object on earth is weighed according to the acceleration due to gravity produced by the earth. Huh? Okay, produced by the earth. So its SI unit, gravitational unit of force, is kilogram weight. It is defined as that much force which produces an acceleration of 9.8 meters per second square in a body of mass 1 kg. Next, so 1 kilogram weight is equal to how much? 9.8 newtons. This becomes the third quantity. 1 kg weight is equal to how much? Either 10 newtons, if you take the acceleration due to gravity to be how much? 10 meters per second square, or 9.8 newtons. It is up to you. Whichever makes your calculation easy, you will do that. Okay. Now, in centimeter grams second system, the gravitational unit of force is gram weight or gram force. It is defined as a force which produces an acceleration due to gravity of 980 centimeters. 980 centimeters is equal to 9.8, right? 9.8 meters per second square. So 980 centimeters in an object of mass 1 gram. So what does 1 gram weight become equal to? 1 gram weight becomes equal to 980 gram centimeters per second square, or simply how much? What is gram centimeters per second square? Dyne. 980 dyne. Now, the relationship between newtons and dynes, I've already told you, it is 10 to the power 5 dynes. Okay. Now, the acceleration unit in g times the corresponding absolute value. A gravitational unit of force is used to express the weight of the body. The weight of a body of mass 10 kgs is 10 kg weight, or how much? 100 newtons. Okay, 10 kg weight or 100 newtons, or to be more precise, 98 newtons. Understood? So kilogram weight is how much, Drupad? 1 kilogram weight is how much? 9.8 newtons. Okay, very good. Now, if an electron is subjected to a force of 10 to the power minus 25 newtons in an X-ray machine, then find out the time taken by electrons to cover a distance of 0.2 meters. Take mass of an electron to be 10 to the power minus 30. So what do we do? Initially, the electron was at rest, right? The electron was at rest. So first things first, we will write this: V, U, A, S, T, M, and F. Okay, so VUAST is something that I always write. VUAST, M at the top and F at the bottom. So we know that the mass of an electron is how much? 10 to the power minus 30. 9.1 into 10 is, oh, basically they have rounded it off. Okay, fine. So the velocity is how much? We don't know. The initial velocity is 0 meters per second, right? It is 0 meters per second because we are accelerating it from rest. The acceleration is coming out to be how much? Okay, 10 to the power minus 25. So acceleration becomes equal to how much will the acceleration be, Drupad? Acceleration is equal to force upon mass, right? What will it be? 10 raised to the power 5 meters per second square. S becomes equal to how much? 0.2 meters, and time we don't know. Okay, so what do we do? What do we do? What do we do? What do we do? We don't know the time, right? We don't know the time. Oh, we have to find out the time. Okay, so we have three quantities U, A, S, T. So we can use the second formula. S is equal to UT plus half A T square. S is how much? 0.2 is equal to UT becomes equal to 0 plus half into acceleration is 10 to the power 5 and T squared. So what do I get? So 0.4 is 0.4 upon 10 to the power of 5 is equal to t square, and if I bring it up it will be 0.4 into 10 to the power of minus 5 is equal to t squared, or 4 into 10 to the power of minus 6 is equal to t square. Therefore t becomes equal to root under 4 into 10 to the power minus 6 is equal to 2 into 10 to the power minus 3 seconds. Okay, so you will have 2 into 10 to the power minus 3 becomes what? 2 millisecond. 2 millisecond. Understood? Clear? Any doubts here? Anything? Any doubts? Okay, so this is how we solve this question. Now, here comes the next one. Okay, so what do we do? I have already told you. Once we learn vectors, we have to start applying vectors in every single component, even in force. So, Newton's second law in composite form and its significance. In terms of the rectangular components, the force, momentum, and acceleration vectors can be expressed as F is equal to f of x I cap plus f of y j cap plus f of z k cap. Okay, so this is how we represent the force. Okay, so similarly, we can represent momentum as P of x I cap plus P of y j cap plus P of z k cap, and we have already learned how to what do you say, resolve acceleration. Ax I cap plus Ay j cap plus Az k cap. From the formula of force and vector form for constant m, force becomes equal to what? The rate of change of momentum. So what do we get? We get force is the f of x I cap plus f of I j cap plus f of z k cap. I'll actually solve this down. So what do we get here? We know that f is equal to ma. Okay, so f of x I cap plus f of y j cap plus f of z k cap becomes equal to m multiplied by ax I cap plus ay j cap plus az k cap. So in the forward direction, f of x becomes equal to what? M acceleration in the horizontal direction. F of y becomes equal to what? M acceleration in the y-axis. F of z becomes equal to what? M a of z. So these are the three components that we have for acceleration. We have learned how to resolve these three vectors in these three axes. Okay. Now, a hockey puck. Any doubts here? Any doubts? Any doubts? You can ask any doubts. Okay, fine. So, hockey puck. with a mass of 0.3 kg slides on a horizontal frictionless surface of an ice rink. Two forces act on the puck as shown in figure. The force F1 has a magnitude of 5 newtons and F2 has a magnitude of 8 newtons. Determine the acceleration of the puck. So what do we do here? We first have to resolve this F1 into its horizontal and vertical components. So this 5 newtons becomes equal to what? This will become 5, 5 cos 20, and the vertical component becomes equal to 5 sine 20. We have resolved the vectors in the horizontal and the vertical axis. Similarly, we can do that for F2. What do we get? F2 is 8 cos 60, and this will become what? 8 sine 60. Okay, so these two vectors have now been resolved in the following manner. Okay, so F1 and F2 were given to us. Now we have to determine the acceleration of the puck. Now we have to determine the acceleration of the puck in both the horizontal as well as the vertical direction. So in the vertical direction, what are the two forces that are acting on it? The two forces. Can you tell me what are the two forces that are acting on it in the vertical direction? 8 sine 60 and 5 sine 20. 8 sine 60 and 5 sine 20 are the two forces acting on the puck in the vertical direction. So we have to use the calculator. I think we have to use the calculator. There is no other way to do that. Okay, so what do we do? 8 sine 60 plus, sorry, this is going in the opposite direction. So the resultant will become equal to what? 8 sine 60 degrees minus 5 sine 20 degrees. What will we end up having when we do this? We will end up having 5.22 newtons. 5.22 newtons. Similarly, if we do it for the x-axis, what do we get? We will get 8.7 newtons. Okay, so in the horizontal direction, the puck only has both these forces. Okay, both the forces 8 cos 60 degrees and 5 cos 20 degrees. Both of them are acting upon the puck in the horizontal and the same direction. So if two forces are acting on the same direction, what happens to the forces? They add up. So you will get 8 cos 60 degrees plus 5 cos 20 degrees. Both of them will get added up, and you will end up with a force of 8.7 newtons. Okay, 8.7 newtons. Now we have found the AX and the AY. We have found what? Now we have no, wait, we haven't done that. One second. We have only found the Fx and the Fy. The force on the X is equal to 8.7 newtons. F of Y is equal to 5.22 newtons. That's it. Now what do we do next? We have to find the acceleration. So we have to combinedly divide what is the mass of the puck? 0.3 kgs from both of them to get the acceleration. We know that acceleration is equal to force upon mass. Acceleration is equal to force upon mass, right? So we have to first divide the 0.3 from both of them. Okay, so AX becomes equal to what? F of x upon m, and that comes out to how much? 29.0 meters per second square. 29 meters per second squared. And similarly, AY becomes equal to what? AY becomes equal to 17.4 meters per second square. So AY becomes equal to F of y upon m is equal to 17. I'm doing this because they used 20. Usually, if they had used some trigonometric value that we know of, then it would have been very easy, right? Did they ask you in the exam any questions like this? They asked you only those trigonometric value by based questions, right? Okay. So f of x and f of y. A of y become equal to what? 17.4 meters per second square. Okay, so these are the two forces. Now again, we have the net force becomes equal to what? Ax I cap, sorry, net acceleration becomes equal to Ax I cap plus Ay j cap. So you will have 29 I cap plus 17.4 j cap. And now how do you find the magnitude? You find the magnitude like this: 29 square plus 17.4 the whole square, and you will get the answer. Understood? So you have to resolve the vectors in either of these two axes, and then you have to find the magnitude in order to find the net acceleration. You can even find the direction in which they are going by. How much, how theta is equal to tan inverse ay upon ax is equal to tan inverse how much, 17.4, 17.4 upon 29, and you will get the value. Okay, it is coming out to be how much? 31 degrees relative to the positive x-axis. Okay, so this is how you make the whole resolution possible. Clear? Any doubts in this vector space question? Okay. If they just instead of 20, if they had given it as a 30, then it would have been an all-round number, right? 30 would have been better. We could have solved the whole question ourselves. Next, a force applied on an object of mass 1 kg produces an acceleration of 8 meters per second square. Okay, so mass is given as 1 kg, acceleration is given as 8 meters per second squared. Okay, and when a force of the same magnitude is applied on a carton of ice cream of mass m2, okay, carton of ice cream has a mass of m2, okay, it produces an acceleration of 12 meters per second square. So this is a1, this is m1, and this is a2 is equal to how much? So 12 meters per second square. 12 meters per second square. Okay. What is the mass of the carton of ice cream and the magnitude of force? Both the forces are equal, right? They have the same magnitude. If both the forces are equal, can I write it like this? F is equal to m1 a1 plus m2 a2. Can I write it like this? Sorry. M1 a1 is equal to m2 a2. Okay, so M1 A1 becomes equal to what? 8 newtons is equal to M2 multiplied by 12 meters per second squared. So M2 becomes equal to how much? 8 upon 12 is equal to 2 upon 3 is equal to 0.66 kgs. Kgs, right? Kgs. So this is the mass. 0.66 becomes 0.67 kgs. Rounding it off. 0.67 kgs. This is the value of the mass M2. Clear? Any doubts? No doubts, right? Okay, fine. So now what is the force that is acting on it? 8 newtons of force is acting on both the objects. Clear? Okay. Next. This chapter is pretty easy, right? I think that's the reason. Like, I thought this chapter would be hard. Okay. A bullet of mass 0.04 kg moving with a speed of 90 meters per second enters a heavy wooden block and it is stopped at a distance of 60 centimeters. What is the average resistive force exerted by the block on the bullet? Very good question. Now, we have a bullet of mass 0.04 kg. So, M is equal to 0.04 kgs. Okay. with a speed of 90 meters per second. U is equal to 90 meters per second. Okay, enters a heavy wooden block and it is stopped at a distance of 60 centimeters. V is equal to 0. A is equal to question mark. S is equal to how much? 60 centimeters, that is 0.6 meters. And what is the average resistive force exerted by the block on the bullet? Okay, so we want to find, so the amount of force that is used, the force exerted by the bullet on the block should be the same as the amount of force exerted by the block on the bullet. You know how this comes? How conservation of momentum, that is fine, but what about Newton's third law? Every action has an equal and opposite reaction. Okay, so what is happening here? First, we need to find the acceleration with which the bullet stopped, and we don't know the time. Okay, we don't know the time, so we have to work with these principles. So we know the value of s, we know the value of u, v, a, and s. So we will use the formula v square minus u square is equal to 2as. So what happens? 0 0 minus 90 the whole square is equal to 2as. As is how much? Why am I writing as again? 2 into 2 into a into s is how much? 0.6. Okay, so um, minus of 8100 is equal to 1.2a, 1.2a. So a becomes equal to how much? Minus 8100 upon 1.2. What are we going to get? We are going to get minus 6750 meters per second. Okay. So a is equal to minus of 6750 meters per second square. Clear? Okay. Now, what else do we have to do? We have found the value of acceleration as this much. Now, basically, the bullet is decelerating, right? The bullet is decelerating. Now, the force exerted by the bullet should be equal to the resistive force of the block. So, they have given us the mass of the bullet. They have given us the mass of the bullet, and we know the acceleration. Am I right? We know the deceleration of the bullet. So basically, the force exerted by the block on the bullet will become equal to how much? 0.04 multiplied by 6750. That will be the amount of force acting on the bullet. Now, Drupad, is this force going to be positive or negative? Why is it going to be negative? Exactly, it is acting against the bullet. So the force acting, the resistive force exerted by the what is the average resistive force exerted by the block of the bullet? Okay, so that is going to be F resistive is equal to M into A, which is equal to 0.06 0.04 multiplied by negative of 6750, and that is the answer for your question. You will get somewhere around 270 newtons. And how do we get this 270 newtons? Because of Newton's third law, which states that every action has an equal and opposite reaction. The bullet was putting a force of this much, 270 newtons on the block. The bullet was exerting a force of 270 newtons on the block. So the block will exert an equal and opposite force of 270 newtons on the bullet. So this becomes equal to how much? This becomes equal to this much value. Clear? 270. So the actual resistive force, how did we get the concept, the logic behind the question? You understood? Okay, let's move on. Okay. So the motion of a particle of mass m is described by y is equal to ut plus half at square. Find the force acting on the particle. Okay, we have to find the force that is acting on the particle. We know that y is equal to ut plus half at square. By differentiating, what do we get? Huh? By differentiating, y becomes equal to v. V is equal to dy by dt is equal to u plus gt. So here, look at this, Drupad. We have y is equal to ut plus half gt squared. Now dy by dt is equal to v is equal to u plus t square becomes 2t, and 2 and 2 gets cancelled, so you will get what? U plus gt. Understood? Okay, a becomes equal to what? Dv by dt is equal to simply g. See, I just kept on differentiating it, right? So a becomes equal to g. Now we know that force is equal to mass into acceleration is equal to mg. So this is the value of force that is acting on the body. So what does it mean? It means that the particle is under the acceleration of gravity alone. It is under the acceleration of gravity alone. Okay, so the given equation describes the motion of a particle under acceleration due to gravity, and y is the position coordinate in the direction of g. Understood how we did it? We just simply differentiated the original equation y is equal to ut plus half at square half gt square twice. The first differentiation gave us what? The first derivative gave us the velocity, and the second derivative gave us the acceleration. Once we knew the acceleration, it is just a piece of cake. All you have to do is multiply the force with acceleration, sorry, the mass with acceleration, and you will get the force. Now, how do I describe how the particle is moving? The particle is moving by going downwards. It is falling down with an acceleration due to gravity of g. So only the gravitational force, the acceleration due to gravity is acting on the object. Clear? Only the acceleration to gravity is acting on the object. Are you able to understand me the way I speak? Is it clear? Okay. I'm practicing a little bit. I'm trying to not use filler words that much. Okay. Now, the next topic that we have is impulse. Do you remember impulse from ninth class? The impulse is what? Impulse is, so today I was teaching students of ninth class the same topic, because we are doing forces and motion in ninth class. And there I told them the same thing that I'm going to tell now. Impact, sorry, the impulse is an impact caused by a force. Okay, it is what? It is an impact caused by a force. Understood? So the large force which acts on an object for a very short time during a finite change in momentum of the object is called an impulsive force. Examples of that are trying to hit a wall. You try to hit a wall like this. Okay, what ends up happening? You basically are applying the force on the wall for a very small time. One of the best examples that I can give you is that of hammering a nail. Understood? What happens when you hammer a nail? Do you basically hammer it slowly? No, right? You basically hit it fast, and the impulse basically travels on from the hammer to the nail. What is happening? The hammer was having an initial velocity u, and then when you hit the nail, what happened? When you hit the nail, what ended up happening? Huh? The velocity of the hammer decreased to zero in a very small time, right? The velocity of the hammer. So basically, when you are moving your hand like this, when you are moving your hand like this, you are generating velocity. Initially, the hammer was at rest, and then we did this. What happened? The velocity increased, but the velocity only stayed increased for a very small time, right? Because the velocity again suddenly became zero. So there was an impact on the nail, and the more the impulse you have, the more will be what? the more will be the impact that the force causes. Okay, so hence, impulse of the a force is defined as the product of the average force and the time interval for which the force acts on the body. It is denoted by I. The impulse is denoted by I. So impulse becomes equal to how much? Force into time. What else is force into time equals? We know that what? We know that force is equal to mv minus mu upon t. This is what Newton's second law states, right? It is defined as the rate of change of momentum. So if I multiply f into time, what do I get? Mv minus mu. Clear? I'll get mv minus mu. So basically, force can also be, impulse can also be defined as the overall change in momentum. The impulse can also be defined as the overall change in momentum of the object as it goes through the motions. Understood? Clear? So the SI unit of impulse is what? Since it's just change in momentum, we can say that it is going to be Newton second or kilogram meters per second. Clear? So it has the same unit as that of momentum. Now, expression for an impulse. Consider a constant force F which acts on a body for a time delta t. The impulse is given as change in impulse is how much? F delta t. Am I right? Okay. If now if the force acts on the body for a time interval t1 to t2, the impulse is given by I is equal to the integration of di is equal to integration of from time t1 to t2 f delta t. Okay, now the f is a constant, so you can remove the f outside. So delta t, when you integrate it, what do you get? T, right? When you integrate delta t, you get t, simply t. Am I right? Okay. Now, when you integrate it to get simply t, so the value becomes t2 minus t1. So f multiplied by t2 minus t1 is equal to I. So the average force, the impulse is defined as what? Impulse is equal to f delta t. As simple as that. F delta t. Clear? Any doubts here? Delta t means what? T2 minus T1. Delta T is equal to T2 minus T1. Okay, next. So, according to Newton's second law of motion, we know that F is equal to dP by dt, right? It is defined as the rate of change of momentum. 1 second. So, we can also say that I is equal to, we know that F is equal to delta P over delta T, or we can say F delta T is equal to delta P. Integrating both sides, so what do we get? F T2 minus T1 is equal to P2 minus P1. We know the value of T2 minus T1 is what? F multiplied by T2 minus T1 is equal to impulse. Impulse is equal to P2 minus P1. So the two formulas for impulse are what? Impulse can either be defined as the force acting on an object for a certain time, or it can be represented as the change in momentum. So these are the two formulas for impulse that I want you to remember. Clear? Okay. So, next, daily life examples of impulse. Following are some of the practical aspects of impulse. A cricket player lowers his hand while catching a ball to allow a longer time to stop the ball. as force is equal to delta P upon delta T. So by increasing the time to catch, the player has to apply a small amount of force on the ball to stop it. So the ball also exerts a small amount of force on the hand. Again, Newton's third law of motion. Every action has an equal and an opposite reaction. So instead of catching the ball like this, instead of catching the ball like, oh, this, it exerted a lot of force, right? It exerted a lot of force like this. But if I catch the ball like this, now what happens? I have increased the time. I have increased the time by extending the motion of the ball downwards. So what happens? I am decreasing the force that the ball is that I am exerting on the ball. Okay, if the force with which I am exerting on the ball decreases, then what happens? According to Newton's third law of motion, the force will also exert less amount of the ball will also exert less amount of force onto my hand. Okay, the ball will also exert a less amount of force onto my hand. And Drupad, I was teaching this today. Okay, now why doesn't the two forces are opposite to each other, right? The ball is exerting a force onto my hand in one direction, and I'm putting a force on the ball in the opposite direction. Why doesn't it cancel each other out and the force becomes zero? Ideally speaking, that's what should happen, right? I am trying to exert a force in the other direction of the ball, in the direction of movement of the ball, and the ball is exerting a force on my hand in the opposite direction of the movement of the ball. Now, why doesn't these two forces cancel each other out and the force becomes zero? What could be the reason, Drupad? Exactly, exactly. Very good. Both the forces act on two different objects. The only way two forces can cancel each other out are if both the forces are acting on the same body. For example, if I keep a block in the middle and ask two people to exert the same force on either directions of the ball of the this thing of the box, then what will happen? The force exerted by one person will be cancelled out by the force exerted by the other person. Therefore, the net force will become zero and the object will not move. Understood? But in this case, what is happening? Both the forces are getting acted upon on different objects. Since they are getting acted upon different objects, the net force does not become zero. Clear? An athlete is advised to stop slowly after finishing a race so that the time of stop increases and then the force experienced by him decreases. That is the reason why after athletes cross the finish line, they keep on running for a few more meters. Okay, so that they can gradually slow down. If the athlete stops exactly at the same point when he crosses the finish line, the amount of force exerted on him will be very high. It will be very high and he could damage his feet. That is the reason why people are asked to run. Again, Drupad, why do people who glide from parachute, when they basically land, they are advised to run? Okay, they are advised to run. Why? Because they are coming down with a large amount of force. Even though the parachute reduces the fall of a person to a very large extent, the force which they are coming down is still pretty large. Is still pretty large, and if the person lands on his feet and stops at that moment, he could fracture his feet. So people are always advised to run a little bit. They should have a dynamic landing. They should not have a static landing when they fall from the parachute. Understood? So that the injury that they feel on their feet reduces to a very large extent. Bogies of train are provided with buffers to avoid severe jerks during shunting of the train. Due to the presence of buffers, the time of impact increases. Thus, the force during jerks decreases. Right? They are basically, there is a large amount of springs between bogies that allows the bogies to slow down not in an instant but slow down gradually, so that the force experienced by each bogie is less. Understood? The force experienced by each bogie is less. Then what would happen? The passengers in the train will have a comfortable journey. Okay, but if there were no buffers, you know what would happen? As soon as the train stops, the force experienced by each bogie will be very large, and it could create a collision. Each and every single bogie could have a collision in between, and they could pile upon each other. They could simply pile upon each other. Understood? That is why toy trains, if you have, I don't know if you have ever played with toy trains. Have you ever played with toy trains? Now, what happens when you place your hand onto the track of the train? They don't have any buffers. They don't have any buffers in them. It is just plastic. So what happens when you place your hand? The train stops instantaneously, and what happens? It derails itself, right? It always derails itself, right? It derails itself and it falls over the rails, and it causes a collision, right? Why did it happen? If it had had buffers, then it would have not have happened. But it's because it's a toy train, people usually don't have buffers in them. They usually have plastic hooks in place which cannot absorb the impact of the sudden stoppage. They cannot absorb the impact of the sudden stoppage, due to which what happens? The train, every single bogie on the train experiences the sudden change in force, due to which what happens? The train derails. Understood? When a person falls from a certain height on a cement floor, receives more injury than falling on a heap of sand. Why? Because the sand compresses itself. The sand compresses itself and allows the decrease in time to be allows an increase in time, so that his velocity gradually decreases, right? His velocity gradually decreases. Instead of a sudden decrease, there is a gradual decrease. Understood? That is why pole vaulting, have you ever seen Olympics, the pole vaulters in the Olympics? So whenever they cross that basically the stick, okay, what happens? Do they fall on concrete or do they fall on a rubber mat? They fall on the rubber mat. Why do they fall on the rubber mat? Because the rubber mat slows down their fall to a very large extent. It slows down their fall to a very large extent, so that the impact that is faced by them decreases. That is why every fighting, like basically, if you take karate or anything, taekwondo or jujitsu, what happens? They have rubber mats in place, so that the impact of the player, the impact of the fighter reduces when he falls onto the ground. Clear? Next. Okay. The batsman hits a ball back a straight. A batsman hits back a ball straight to the direction of the bowler without changing its initial speed of 12 meters per second. If the ball, if the mass of the ball is 0.15 kgs, determine the impulse imparted to the ball. Consider a ball in a linear motion. What is happening, Drupad? When you hit the ball straight back, the velocity becomes what? Initial, if you consider the initial velocity, the initial direction of the ball to be minus, and the final direction of the ball, if the person hitting the ball, if the direction with which the batsman is hitting the ball, if you consider it to be positive, then the bowler throwing the ball, that direction will be considered as negative. So what will happen? Then P2 minus P1 will become double. it will become double, right? Because of the minus sign, the minus minus becomes plus. So what would happen? The initial and the final velocity would get added up. Instead of 12 meters per second, now the ball is actually having a change in velocity of 24 meters per second, right? Because of the negative sign, the ball is having a change in velocity of 24 meters per second. And what does it do? This change in velocity, this change in velocity changes, sorry, this change in velocity, wait 1 second, where was I? I lost my chain of thought. This change in velocity basically increases. Okay, it increases, therefore, the change in momentum also increases. Am I right? The change in momentum has increased. So P2 minus P1 becomes equal to how much? 3.6 kilograms meters per second. It becomes equal to 3.6 kilograms meters per second. Therefore, we know that what is impulse? Impulse is the change in momentum. Change in momentum is becoming 3.6 kilograms meters per second, or the impulse becomes equal to 3.6 newtons second. Clear? So, what was happening? The change in velocity was extreme. Change in velocity was extreme. The impulse imparted by the batsman on the on the bowler will be twice. It will be twice the speed. Clear? Because of the negative sign. Understood? Because of the negative sign, what will happen? The bowler will have to have will experience an impulse of 3.6 newtons. Any doubts here? All we did was considered one direction as positive and the other direction as negative. We considered the batsman's direction as positive and the bowler's direction as negative. Okay. Any doubts? Okay, fine. So consider a ball falling from a height of 2 meters and rebounding to a height of 0.5 meters. If the mass of the ball is 60 grams, find the impulse and the average force between the ball and the ground. Okay, the time for which the ball and the ground remained in contact was zero point 0.2 seconds. Okay, okay, a ball falling from a height of 2 meters per second and rebounding to a height of 0.5 meters per second. Okay, if the mass of the ball is 60 grams, okay, find the impulse and the average velocity. First, we have to consider the velocity, right? Well, the velocity with which it touched the ground, right? Initial velocity will be zero, right? Because it is falling, it is starting to fall. So the initial velocity will become zero. The final velocity we don't know. We know the height, we know the acceleration due to gravity as 9.8 meters per second. So can we find the final velocity? So final velocity will become equal to what? We know that v is equal to u plus at. Therefore, v is equal to 0 plus gt is equal to, oh, we don't know the time also, right? V square minus u square is equal to 2as. Yes. V square minus u square is equal to 2as. Therefore, v square is equal to u square plus 2as. V square is equal to 0 plus 2 into 9.8 into, did they use 10 or 9.8? They use 9.8. Okay. 9.8 multiplied by S is how much? It is falling from 2 meters, right? It is falling from 2 meters. So V square becomes equal to how much? Uh, 4 into 9.8. So V becomes equal to 2 root under 9.8. Hmm. What is root 9.8? 3.2. Are you sure? 4 into 9.8. Yeah. Is coming out to be 3.2, 3.1 something, Drupad, right? Okay, so V becomes equal to how much? 6.26 meters per second. This is the value of V. Now, okay. Now, then it rebounds to a height of 0.5 meters. So the initial velocity with which the impact happened was 6.26 meters per second. Now we have to find the final velocity. Okay, the initial velocity of the in a rebound. So how do we solve this? So it had an impact. So the final velocity in the first case became the initial velocity of the impact. Okay, the final velocity in the first case became the initial velocity of the impact, and the initial velocity in the first case becomes the final velocity of the impact. Did you real understand what I said? If you didn't, I can repeat it again. So, understood, right? So, we have to calculate the initial velocity now. Now, in the second case, what happens? Again, VUAST. We know the final velocity. When it goes up, it reaches zero. When it reaches 0.5 meters, the final velocity becomes zero. The initial velocity is question mark. The acceleration is minus 9.8 meters per second. S is zero point 0.5, and again, we don't know the value of t. So, what do? We use the formula v square minus u square is equal to 2as. So 0 minus u squared is equal to minus 2 into 9.8 multiplied by s is 0.5. So again, what happens? This 0.5 and this 2 can be get cut off. So minus u square is equal to minus 9.8. So u becomes equal to what? This minus minus gets cut off. Root under 9.8. So what is root under 9? Well, we should have figured out what 9.8 was. So, but why is it positive? Why, it should be positive, right? Or have I made a mistake? Oh, hmm. Why is my velocity not coming out to be negative? But why is my velocity not coming out to be negative? And I also did. Oh, they made a mistake, right? That's what you're trying to say? Yeah, they made a mistake here. So this should have been minus. Clear? So what we did is correct only. U is coming out to be 3.13 meters per second. Correct only. Okay. Now, this value of U is in, see, the logic that they give is stupid, but the final answer is going to be correct because we are going to consider the downward direction as positive and the upward direction as negative. Understood? Okay. Now, what do we do? If we consider the upward direction to be negative, so what happens? So, mv minus mu. Okay. So, what is the mass? 60 grams. So, this can be 0.06. So, the impulse will become equal to how much? impulse is equal to mv minus mu. Okay, so impulse is equal to mv minus u is equal to, what is the final velocity? No, that's the initial velocity, right? The final velocity is 3.13 when it is going up. Hmm. No, what they did was they considered the upward direction as positive and the downward direction as negative. Okay, so they have considered the upward direction as positive and the downward direction as negative. So then it makes sense. The upward direction is 3.13 and minus the downward direction was how much? 6.26, right? So minus of 6.26. So minus minus becomes plus. So what do you get? 0.06 multiplied by 3.13 plus 6.26. So there are a lot of details missing in this question. Okay, okay. So they considered the upward direction to be positive and the downward direction to be negative. So then and only then you will get the impulse as this much. Okay, 0.0. So you will get 93.9 multiplied by 0.06. So what will be the final answer? The final answer will become equal to 0.563. 0.563, right? Yeah. So this will become equal to 0.563 Newton second. Okay, this is the formula for impulse. But the question is not over yet. They are asking us to find the impulse and the average force. We know that impulse is equal to what? Force multiplied by delta S, right? So, delta T. I'm so sorry. Okay, in my head, I was thinking about seconds. F multiplied by delta T. So, F becomes equal to I upon delta T. So we know the change in that impulse is how much? 0.2 seconds. So force becomes equals to 0.563 upon delta t is 0.2. So 0.2 becomes 1 by 5, 1 upon 5. So 5 into this value. It will be somewhere around 2 point something. Yeah, 2.817 newtons. 2.817 newtons. So this is the average force that is acting upon the body. So what all did we do in this calculation? First and foremost, we took the logic was the downward direction was taken as negative and the upward direction was taken as positive. Okay, so basically the final velocity in the downward direction became the initial velocity of the impulse, and the initial velocity in the second case when the ball was moving up became equal to the final velocity, right? Became equal to the final velocity of the impulse. So the impulse became equal to the change in momentum. Whatever change in momentum that we got basically became the answer. And then at the end, what happened? We had to find the average force. When we calculated the average force, how did we do it? Impulse upon time. Impulse upon time gave us the average force. Am I clear? Okay. So this is how we were able to solve for this question. Any doubts in this question? Okay. So we will start with Newton's third law of motion in the next class. Okay. In the next class, we can start with Newton's third law of motion. Understood? So did you like the lesson today? Okay, so we will finish this in 3 days. Okay, today is the first day, second day, and third day. We'll be able to finish this chapter again. Okay, and then we'll move on to the periodic classification of elements. Understood? Okay, so okay, students. So I'm gonna end my lecture here. If you liked my lecture, please do like, share, and subscribe. And if you really liked the way I'm teaching, please spread this across with your friends so that more people can watch, and it'd be a really great help for me. So please do like, share, and subscribe, and have a nice day. Okay.